Hello everyone, welcome back to A4 Analysis. This is the sixth episode of Study Statistics with me. Here we talk about sampling and sampling distribution. Sampling is widely used in business as a means of gathering useful information about population. Now, whenever we want to make a business decision about a population, it is not possible to gather data for each and every entity of the population. So what we can do is we can take a small sample, or we can gather information about a small part of the population, and based on what we see for that particular sample, we can make some decision about the population. But of course we can't just do it without any rules or regulations. This is where we will talk about how we can um, select the sample and what are the things we have to consider while sampling, and what kind of sampling distributions are there in statistics. So there are few advantages of sampling as mentioned here. Number one is sampling can save a lot of money and time, because of course we are not gathering information about each and every entity of the population. Rather than that, we are gathering information only for a small amount of entities, small number of entities. Number two, the sample can broaden the scope of study for given resources, because we are making the number of entities small, so that's why it is possible to explore more things for those small number of entities. Number three is sampling can save products when research process is destructive. This is a very good example. Say for example, we are working with light bulbs and we want to know how long they can burn. And if we want to test all the light bulbs we have produced, then we will end up burning up all the light bulbs and we'll end up destroying all of them. Instead of that, to know how long each light bulb can last, we can take a small sample, we can do our experiments on that, and based on our observations, we can make a comment on the entire batch, or on the entire population of light bulbs. Number four, sampling could be only option when accessing the population is impossible. So of course, if the population is very large, and or it's really very expensive to gather data for all the population, then of course sampling is the only possible way. But there are other cases when we can't go for sampling, or we have to go for census. Number one, census can be chosen, means we have to gather data for the entire population instead of sampling, to avoid the possibility of randomly selecting a sample that is not a representative of the population. Number two, for safety of the consumer. So this one we can give an example, like the sampling, whatever we want to use the sample for, the sample has to be a good representation of the entire population. But if the sample is not good enough representation of the population, in that case sampling is not good, census has to be chosen. In where in such use cases where it is really very critical to not make any mistake or not make any error, in such cases we have to go for census. And of course, for safety purposes also, in some use cases we will go for census instead of sampling. Next, there is a terminology called frame. Every research study has a target population that consists of individuals, institutions, or entities that are the object of investigation. The sample is taken from the population list, map, directory, or other source used to represent the population. This list, map, or directory, these are the things which are called as the frame, which can be school lists, trade association lists, and so on. Ideally, one-to-one correspondence exists between the frame units and the population units. In reality, the frame and the target populations are often different. Next, we have random sampling and non-random sampling. If every unit in the population has the same probability of being selected into the sample, it is called probability sampling or random sampling. Means every sample will be as random as possible. There is no chance that one entity has a greater chance or a greater probability of getting selected than another entity. Similarly, if every unit in the population does not have the same probability of being selected into the sample, it is called non-random sampling. Means the probabilities are not equal for all the units. It's slightly up or down. In such cases, it will be a non-random sampling. Assigning the probability of occurrence in non-random sampling is impossible, hence it is called non-probability sampling as well. Now let's see some of the random sampling techniques. In statistics, of course, we will be more focusing on the random sampling techniques. The first one is simple random sampling. In simple random sampling, each unit of the frame is numbered from 1 to capital N, where capital N is the population size. A random generator is used to select small n items into a sample. Small n is actually the sample size. These are the notations we will use throughout statistics, where capital N will be population size and small n will be the sample size. Next we have stratified random sampling. In stratified random sampling, the population is divided into non-overlapping subpopulations called as strata. The researcher then extracts a random sample from each of the subpopulations. So first, we are collecting the non-overlapping subpopulations, means they don't have any common units, they're completely different, and then from those strata, we are making our final sample. This type of sampling is used to ensure the sample is a good representation of the population. So just a few minutes back, I was talking about this, whether our sample is a good representation of our population or not. In order to make sure that the sample is actually a good representation, means it has all sorts of type of units, means if there are, say for example, we want to take a sample of population where we want to make sure that there are many different kinds of races. So if we want to select and we want to conduct a survey, for a stratified random sampling, we are doing like for each race we are taking 10 people separately, and then from all those strata we are making the final sample, in order to make sure that from every race we are getting at least some of the units, or at least some of the people are coming from every race. So in order to make sure that we are getting a good representation of the population, we use stratified random sampling. Of course, it will be costlier because here we have to add some more human intervention, and we have to really make sure that we are getting units for every strata. Internally, a stratum should be relatively homogeneous. Externally, the strata should contrast with each other. Means, say for example, we are talking about this survey, right, where we want to make sure that there are many different kinds of races available in the sample. So for one sample, say for example, we are taking Asians. Within one sample, all should be Asians, mean there should not be much difference. But if we are comparing this stratum with another one, it should be quite different. So there should be some difference between the two strata. Then proportionate stratified random sampling occurs when the percentage of the sample taken from each stratum is proportionate to the percentage that the stratum is within the whole population. So if we are able to maintain the proportion, then it will be a proportionate stratified random sampling. When the proportion of the strata in the sample are different, then it is a disproportionate random sampling, which is also possible, of course. Next we have systematic sampling. Now systematic sampling is used for its convenience and relative ease of administration. With systematic sampling, each kth item is selected to produce a sample size of n. from a population size of capital N. Now the value of k, the sampling cycle, can be determined by following formula. If k is not an integer value, the whole number value should be used. K is actually the population size divided by the sample size. And if it is not coming up as a whole number, we have to take the nearest whole number. The problem with systematic sampling can occur if the data is subject to any periodicity. Say for example, we want to make a sample of the students and we are taking every maybe 60th student. So if we want to take every 60th student in the whole class, and if we have every section as almost like 59 student, 50 to 59 students, so every time we are taking 60th, since there is a cyclicity in the data, means probably the roll numbers are merit wise, or there is some scoring method available to make the roll numbers, and if we are taking the 60th roll number every time, either we can get the top students or we will get the last, like the last few students of the class. So if the students are randomly distributed, if the roll numbers are randomly distributed, in such cases, means there is no cyclicity. If we take 60th student from each class, we will still have a good sample. But if the data has cyclicity, in that case, cyclicity or periodicity, in such cases, the sample would not be random anymore. Cluster or area sampling. Area sampling involves dividing the population into non-overlapping areas or clusters. However, in contrast to stratified random sampling, which we talked about just a minute ago, where strata are homogeneous within, the cluster sampling identifies clusters that tend to be internally heterogeneous. In theory, each cluster contains variety of elements. The cluster is actually a miniature of the population. So the difference with stratified sampling and cluster sampling is that in stratified sampling, the inside the strata, the data is sort of homogeneous. But in this case, within each cluster, there is heterogeneity. And because the cluster is actually a miniature of the population. One researcher has randomly selected clusters out of the population. He or she either selects all the elements of the chosen cluster or randomly selects individual elements into sample from the cluster. He or she can select randomly because, again, the cluster is actually a miniature form of the population. That's why he or she can take the complete cluster, or he or she can take few random units from them. If the clusters are too large, a second set of clusters are chosen from each original cluster. This technique is called two-stage sampling. Cost and convenience are the two most important advantages of cluster sampling. On the other hand, if the sample of clusters are similar, elements of clusters are similar, cluster sampling may become statistically less efficient. So here the most important thing is the cluster. Within a cluster, there should be enough heterogeneity, or it should be a good representation of the population. If that's not happening, then this is not very useful. Then comes non-random sampling. Non-random sampling we already talked about, where the probability of one unit being chosen for the sample is not always equal. So it's not random. Convenience sampling, these are the few types of non-random sampling. These are also used sometimes, but not very reliably, of course. So convenience sampling is when the elements of the samples are selected for convenience of the researcher. The researcher usually chooses elements that are readily available nearby or willing to participate. So I want to conduct a survey, and instead of making sure that I am getting all sorts of age groups or different genders, equal distribution of the genders or equal distribution of the races. I'm just standing on the road, and whoever is willing to participate, I'm just conducting the survey with them. So that will be a convenience sampling. Judgment sampling is another non-random sampling. In judgment sampling, the elements are selected for the sample by the judgment of the researcher. The sampling error cannot be determined objectively because this is non-random selection. There is no probability, that's why we cannot find the sampling error. Also, the researcher may tend to make errors of judgment in one direction. These systematic errors can lead to biases. Next comes quota sampling. Quota sampling appears to be similar to stratified sampling. Again, there must be a difference. Instead of randomly selecting from each stratum, the researcher uses non-random sampling method to gather data from one stratum until the desired quota of the sample is filled. So in stratified sampling, we have to, after getting all the strata, we have to randomly select few units from each strata. But here, in this case, we have to fill up the quota, and that should be our only goal. Quotas are described as quota controls, and which set the sizes of the samples to be obtained from the subgroups. Generally, a quota is based on the proportion of the subclasses of the population. Next is snowball sampling. Survey subjects are selected based on referrals from other survey respondents. The researcher identifies a person who fits the profile of the subjects desired for the study, and then they will be asked for few more names who will be available for the survey or available for the study actually. Sampling error. Sampling error occurs when the sample is not a good representation of the population. Sampling error can occur by chance in case of random sampling. But for non-random sampling, we cannot really calculate the sampling error because the probability itself is not known to us. Non-sampling error, all errors other than sampling error, missing data, like recording errors, input processing errors, defective questionnaire, response errors, all of these errors will come into the category of non-sampling error. So that's it for sampling and sampling distribution. If you guys found this video useful, please like this video, share and subscribe to my channel, and we will meet again very soon. Bye guys.